welcome to my YouTube channel. So in this particular video, we will talk about an applications of machine learning or AI in healthcare domain. A lot of students have requested me for this video, and even a few weeks back I gave one workshop also in one of the college related to this only. So I'll just share the gist of what are the applications we can have in a healthcare domain. And this domain is something which I would say is not completely boosted as of now. There is so much scope where we can do a lot of research with respect to how we can automate the task in the healthcare domain, right? Which will be really helpful for social goods as well, and even will be helpful for the doctors also. So let's get started. But before coming straightforward to the point, here I just want to talk about a little bit gist of the very intro part. I hope that everyone knows the basics of these AI, ML, and DL. But still, let's get started with this point, that what is the difference between AI versus ML versus DL? What do you think? So we all know that whenever we are talking about artificial intelligence, it's a bigger circle, yeah, where I would say a complete end-to-end system will be there. So there is some intelligent machines which are working internally, which is able to take the decisions just like the human beings take, right? End-to-end system is there. Now, when we are talking about machine learning, that comes under the category of AI. So when AI is a bigger circle, so inside AI we have ML. What is ML? Where we are trying to learn the machine without being explicitly programmed. What does that mean? Means I am trying to pass the historical data on the basis of which my machine will be able to give me the predictions. Without any human intervention, my machine will be able to take the decision and is able to give me the predictions on the basis of how? On the basis of the past data which I have inserted inside my model of the machine learning. Now, everything was going so far so good, right? As you can see that in 1950s, it's not that just now we have seen the word AI. But yeah, I can say that the boom is now, but 1950s itself, AI already have developed. After that, what happened? Machine learning came. But then as we move towards 2006, 7, 8, 9, 10, as you can see that when the time passes by, the data frequency is quite high. Everyone is on the social platform, whether it be of Instagram, whether it be of LinkedIn. A lot of data is there with respect to each and every particular aspect, right? In that particular case, what happened? Machine learning models were not able to perform pretty well when the data size was too huge. At that point of time, researchers developed something called as deep learning, which is again a further subset of, I would say, machine learning. So AI is the bigger circle. After that, machine learning is a part of that particular bigger circle, and deep learning is also a subset of machine learning, I would say. So here the learning is based on deep neural networks. It would be inspired by the human neurons, that how basically human neurons will work, right? After that, what happened? Whenever we are talking about the machine learning part, we usually have three different categories of machine learning. One is supervised, where we will be having a labeled data, right? Suppose you are doing any kind of a task, your target column is also given to you inside your data set. That is something which we are calling it as a supervised machine learning algorithm. For example, let me give you one example. For example, you are solving one classification task. Means you want to classify that whether this particular record belongs to A class or B class. So what will happen? At that point of time, if suppose the target column is given to you, where it is indicating to you that, okay, it is belonging to A and it is belonging to B, that is something which we are calling as a supervised learning. Now, in supervised learning, we have two further different types of problems. One is I just said few minutes back, classification, where you want to classify that which class it belongs to. Another one is called as regression, where what you are trying to do, you are trying to predict some continuous data. Here in classification, you are predicting some discrete value. In regression, you are predicting some continuous value. For example, I want to predict house price prediction data. So what is given to me is the data set which is having different features. For example, how many number of bedrooms we have, what is the space size, right? According to which there is already a house price which is written to us. Now we are applying a regression algorithm in the machine learning to give the prediction of the test data, right? So what is happening here? We are trying to pass the historical data on the basis of which we are expecting our model to predict for the test data, right? Another part is the unsupervised learning, where there is no as such labeling is given to us, right? Meaning that target column which I am talking about here is not given in case of unsupervised machine learning algorithm. Here basically the technique which we call as clustering, which is basically we're trying to group different clusters based on the properties that they have. For example, I want to do the customer segmentation task, right? I want to segment the customers according to how much their spending score is. For example, there is some customers whose spending score is really high. I will group them in one part, and I will group those customers which is having a very low spending score into another part. So here basically clustering is happening according to the common properties that they exhibit. We try to create a cluster out of that. And the third one is something which we call as reinforcement learning, where what will happen is that model take the actions in the environment, it receives some feedback, and according to that it will try to respond. Very good example is the self-driving car, right? What usually happens, we as a self-driving car, there is a reinforcement learning which is coming into picture, and we are trying to penalize whenever the car is seeing the obstacle and is not taking a brake, right? This is how, according to the environment feedback, model is trying to learn. Either we are giving a reward or we are penalizing that particular model. This is something, an example of reinforcement learning. Now moving ahead, what is the complete life cycle of a data scientist? Whenever we are talking about a life cycle, first of all, we have to understand the business problem. Basically, what we want to predict and what impact did that have according to our business, right? Then only we can start our problem statement, where we can start collecting the data. That is the second step where data collection will start. After collecting the data, we need to do the data preparation, where obviously the data which we have collected is the raw data. We need to prepare that data in such a way that, okay, we will be having these features, and correspond to these particular record, we will be having the target column. After that, once data preparation is done, we are trying to start with the EDA task, exploratory data analysis. What we are trying to do here is that we are trying to find out that whether the data contains the null values or not. If yes, how we can do the imputation, whether the given data contains the outliers or not, because if yes, we need to take care of that. Either we can remove them, or we will try to treat them differently with the help of different cost functions that we have. After that, the next important part is the data modeling. So here, in complete life cycle, if you will ask to me what is the really important part, I'll say that EDA. So why? Because EDA is where you are filtering your data in such a way that whatsoever outliers, whatsoever null values, or whatsoever high correlation coefficient features are there, you are trying to remove that, right? So the good filtered data is the good results you will be able to get. That is very simple thing, right? So here you will try to now do the modeling on the basis of what kind of problem you are trying to solve. For example, you are trying to apply a machine learning model. In that case, you have to understand, first of all, that whether it's a supervised data or it's an unsupervised one. Means whether the target column is given to you or not. If it is given, then you have to think, okay, it's a part of a supervised. Then in what category it come? It came under classification or the regression. And according to that, you will apply the different kinds of models. Now, after applying the model, it's really important to evaluate that okay, your model is giving the prediction, but how accurate that prediction is with respect to the actual predictions that we have. According to, again, different kinds of problems, we do have different kinds of evaluation metrics. And the final task is the model deployment, where obviously that as a user, I don't know what is model evaluation, what is accuracy. What I know is that I want one good web page where I will be able to insert the data and I will be able to get the predictions. This is what I want, right? So this is where model deployment will come into picture. So this is the complete overall life cycle of any data science project that we will do. Now coming towards the point where this question is asked by so many students. So what do you think are the prerequisites required to learn ML or AI or data science? What do you think? So here, if you will observe, the important prerequisites to understand these things is, first of all, you should have a good understanding of any one programming language, either Python or R. Okay. Apart from that, you should have a really good knowledge about the mathematical concepts related to stats, related to linear algebra, related to probability. These things are pretty much important. Why? Whenever you are doing EDA task, these things will play into picture. I hope you all know in data science lifecycle, just now I showed you the very important step, which is EDA, exploratory data analysis. So there stats plays a really important role. After that, in order to understand different kinds of algorithms, you do require a practical knowledge of linear algebra, probability concepts, right? Apart from that, DSA plays a pretty much important role whenever you are learning data science. Why? Because for sure, okay, you can create one code, you can write a code, but how will you do the optimization of that if you don't know the basic concepts of data structure and algorithms, right? So optimization part will be done only by those people who are good with this DSA, who are good with the problem solving skills, right? Who are good with how basically we can evaluate time and space complexity and how we can reduce that, and what impact we have when we will try to reduce those time and space complexity. After that, database, we are specifically saying SQL again plays a really important role. So please try to have a good command over these particular topics which I have written in this particular slide, right? Now let's talk about now the important aspect of this session, that is, what are the applications of AI in healthcare domain? So as of now, you will see that there are a lot of applications, but still what I am saying is that there is a lot of scope which I can see, which is there. I hope that the researchers, those who are in AI domain working day and night, they will be able to make unique changes in the future as well. So for example, we want to detect the cancerous cells. So what will happen? This is something which is happening nowadays as well. So we will be having a CT scans, non-contrast and the contrast CT scans are there. When I am saying contrast means we will be having a more clear picture of the CT scans. So what will happen is that, first of all, the first purpose is to extract the region of interest where we want to get the cells of the cancer, right? This is the very first step whenever you are solving any a project of healthcare domain. If suppose the CT scans is given to you, first of all, you have to have an idea by consulting with doctors, right? That at which particular area those cells are more there, right? We need to find out that region of interest by applying different kinds of algorithms, right? Maybe you can apply CNN based models like UNit plus, or you can apply non-CNN based models as well. For example, capsule networks. So here, what will happen is that once you will be able to find out those region of interest, what will happen? You will apply newly developed algorithms, just like the way I said to you, whether it be a CNN and non-CNN. So what will happen? Here you can observe this red point, right? This is something which is the prediction given by the model that this is something which is a cancerous cells that we have. So now what will happen is that somehow we all know that there is a scarcity of radiologists in India. If suppose these kind of fully automated machines will be put in the cities where there is no that much highly qualified doctors are there, what will happen? At least they will get to know that, okay, their problem is really severe and they can go to the big cities and then they can do the treatment pretty well, right? This is how these kind of things can happen if we will pay a pretty much good attention towards these kind of models. Once again saying that whenever we are talking about any application of AI in healthcare domain, we can't rely on the model evaluation metrics only. That is accuracy score, DICE score. No, we can't rely on those aspects because we don't know, even though the number is less, but doctors are saying that results are quite fine, we have to go with that. So in these domains specifically, what I want to say is that the doctors plays a pretty much important role, because we as engineers don't know that what is good, what is bad, is this cells is correct or not. So they will provide you some sort of specific number with the help of which you will be able to find out some correlation metrics, and you will see that higher the correlation value or correlation coefficient value, that only you will be able to take as a final model or final weights, right, to get the predictions. Similarly, if I will talk about my project where I did my thesis work on healthcare domain itself, where the task is to basically detect the ground glass and the consolidation in the CT scans. So again here, if you can see, this yellow based images are the infectious portion inside the lung. So again, the task is first of all to get the region of interest. CT scans are given to us. We all know that inside the lung only that portion of infectious portion will be present. So the very first task is to get the region of interest, and after that what we can do, we can just detect those ground glass and consolidation or the inflammation region by applying the different kinds of models that we have for the segmentation task. Here specifically, I have worked on all the CNN and non-CNN based models, and specifically two models work best, that is unit plus plus and segcaps, and this is what we have written here. Both of the results are pretty much good, but here then we try to compare the performance of unit plus plus and segcaps based on some statistics metrics, right? These things I already shared in one of my video where I have talked about in much depth about my research paper, that you can watch, but here I'm not going in that much depth. And this is the publication which I published in EMBC conference. Again, I already have shared this in my previous video, so I will not go in much depth towards that part. Now, basically, the purpose of overall this project is that, is my patient required ICU or not, right? Is my patient likely to get COVID again or not? Is my patient required mechanical ventilation or not? Is there any chance of patient to get readmitted? These answers we only able to get once we would do the training pretty well, right? After that, here again, if you will see, this is one of the project by Google, AI Arman project, which I found it pretty amazing, the way they are working day and night in order to, you know, save the child, save the women who are pregnant. Please watch this video. I'm linking the reference here. You can just open this. I'll attach this PPT in the description part of my video, and please do see this video and try to see that how this AI is helping in healthcare domain pretty well, and how much there is a scope in future as well to do the advancement on top of that and save our you know, community, society in a way. Specifically, I'm talking about low areas where there is no that much, you know, frequency of highly qualified doctors. I myself belongs to a very small city where there is not that much highly qualified doctors are there, and associated with my city there are all the villages. So I can see that there is a lot of need where we can do something good with the help of this AI in specifically healthcare domain, right? If you have any sort of queries, do ask me in the comment section, right? And do let me know what other things you are expecting from me in my YouTube channel. I'll try to share whatever experience I do have. If I have, definitely I'll share, right? And if you have any sort of queries with respect to this particular video also, do let me know in the comment section. You can just ask me the queries via my LinkedIn ID or my YouTube channel in the comment section, anywhere, whatever you feel is comfortable. And with this, I would like to end this particular video. Please share this video to as many people as you can. Subscribe to the channel, and this will really mean the world to me, right? So with this, happy learning to all. Bye bye everyone, and I'll see you all in my next upcoming video.